Okay, so now we're going to take a look at an example here. Given the graph of x plus 2 quantity cubed minus 1, determine if it has an inverse. If so, use points on f to graph its inverse. Well, here's the deal. First off, it does have an inverse because we could run the horizontal line test here, right? And we would see that it's 1 to 1. All right. Next, in order to graph its inverse, we have to realize there are certain points on this graph here, okay, that will help us find our inverse. So if I take a look here at f of x, you notice I found some points, like 0, 7 is a point, -1, 0 is a point on our function, -2, -1 is a point, -3, -2 is a point, and then our last one here that I have on there is -4, -9. Okay, now what's nice about this is on its inverse, and maybe I'll put these in red so we can distinguish those from the graph. Okay, well, it's not letting me do it, so I'll just erase it and then make it red. Okay, these are our points in red. Then on its inverse, which I'll do in blue here, all I have to do to obtain points on my inverse are flip these. So 7, 0, flip the x and y. 7, 0, 0, -1, -1, -2, -2, -3, and -9, -4. These are all points on my inverse. So if I start to plot these, for instance, 7 zeros here, 0, -1 is here, -1, -2, -2, -3, and then -9, -4 puts me right here. You'll notice you can see the inverse coming together here. Okay? And we got that just by switching our x and y values. Now you'll notice that the line of symmetry between f and its inverse is the line y equals x. So in other words, you could just reflect the graph of f over the line y equals x, and it's symmetrical with that. But a way that we can do that is just by flipping the x and y values.